So the topic of this video is properties of chords. Our objectives: I can define and identify chords. I can understand the relationship between chords and arcs in a circle and can use this to find the unknown values of the two. So, in the same circle are also congruent circles, two minor arcs, and remember a minor arc is less than 180 degrees. Two minor arcs are congruent if and only if their corresponding chords are congruent. So if we want to find the measure of arc FG here down the bottom, we have to first make sure that we have congruent circles and we have congruent radius or congruent radii. So that means the circles are congruent and we have congruent corresponding chords. So the measure of arc FG equals 80 degrees. If one chord is a perpendicular bisector of another chord, then that first chord is a diameter. So we see here SQ bisects TR, there should be a T here, TR, and it also is perpendicular, so it's a perpendicular bisector, so we can say SQ is a diameter. And if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So here we have a diameter, EG, passes through the centers, and it is perpendicular. So we can say it bisects FD, and it also bisects the chord, or the arc, FGD. So a couple examples. First, in the top one, we want to find the measure of segment FB. And since we have a diameter here from A to G, it's also perpendicular. We know that it bisects the chord DB. So FB equals 10 because it is congruent to DF. And we want to find arc measures in the second one. These should all be arcs. So CD and DE are congruent because, again, we have a diameter that is perpendicular to a chord. So bisects, and then the chord and the arcs are congruent. So to first find CD, we need to find the value of x. So we set 9x equal to 80 minus x. If we add x to both sides, we get 10x equals 80. Divide by 10, we get x equal 8. Then to find the measure of CD, we plug 8 in for x, we get 9 times 8, that equals 72 degrees. DE, because we know it's congruent to CD, we can just say is 72 degrees. Otherwise, if you plug x in, 80 minus 8 is 72. Then CDE, we see, is made up of the two arcs, CD and DE, so the measure of arc CDE is the sum of the two arcs. So we take 72 plus 72, and that comes out to give us 144 degrees. Okay, one more theorem. In the same circle, or again in two congruent circles, two chords are congruent if and only if they are an equidistant from the center. And equidistant just means an equal distance. So we have chord AB and CD, and they're both equal distance from the center of our circle E. See, we have the two congruent segments. And so now the example at the bottom, in circle P, PV equals PW, so we have congruent segments, means the chords are an equal distance. From the center, we want to find QR, and QR equals 2x plus 6, and ST equals 3x minus 1. So again, first we have to find the value of x. We do that by setting them equal to each other. 2x plus 6 equals 3x minus 1. If we Subtract 2x from both sides, and also add 1 to both sides. We get 7 equals x. Now to find QR, we plug 7 in for x. We get 2 times 7 plus 6. 2 times 7 is 14, plus 6. QR equals 20. Okay. So now we want to find the measure of arc BC right here. And so we're given the measure of arc AB, it's 116. And now because chord AC and chord CB are equal, we know that their arcs are equal. So we can take 360, subtract 116. That gives us 244. So that's what we have between the two, and since they're congruent, we divide 244 by 2, and we get the measure of arc BC equals 122 degrees. Now we want to find the measure of arc KLM, so this distance here. And we have congruent chords here, JK and ML, so we know that this part of it is 142 degrees. And again, we have congruent chords from KL and JM, so we know this is 38 degrees. To find the total measure of the arc, we add those two together. 38 plus 142. We find that equals 180 degrees. Okay, and one last theorem here. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments in the other chord. So if we look at the illustration here, we have chord AB and DC, and they intersect at point E. So EA times EB equals EC times ED. So we have chords A and B and D, AB and CD that intersect inside the circle. So we want to find the value of x. So to do that, we set the products equal to each other. So the product of the two segments in AB is 18x. And then we set that equal to 12 times 9. So 18x equals 108. Divide both sides by 18. We find that x equals 6. Now to review, we have all our theorems. In the same circle or congruent circles, two minor arcs, again minor, less than 180 degrees, are congruent if and only if their corresponding chords are congruent. If a chord is a perpendicular bisector of another, then that chord is a diameter. If the diameter of a circle is perpendicular to a chord, it bisects the chord and the arc. In this circle or congruent circles, two chords are congruent if and only if they're an equal distance from the center of the circle. And if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the segments in the other. Make sure to go online, do that reflection, get your bonus point, and ask any questions you might have, and I'll see you in class tomorrow.